right, everyone. Can everybody hear me okay? Okay, awesome. So here we are, the first talk of DinosaurJS 2018, and we're here to talk about everybody's favorite subject, testing. All right, so a little bit about me first. My name's Emily Morehouse. I lived in Denver. I've lived in Denver for about 2 years now. I came here by way of Florida, where I spent basically the rest of my life before I moved to Denver. I work for a company called CuddleSoft. We are a digital product development company where I get to work on anything and everything from CI/CD pipelines and system architectures to web and mobile development, UX, and IoT. So I get a chance to touch on a lot of different parts of tech in some really cool ways. I'm also at Emily E. Morehouse pretty much anywhere you can find me on the internet. So let's start off with a quick overview of what you can expect to get out of this talk. So first, we're going to start out with this sort of rapid-fire, possibly rambling introduction to testing. We'll talk about why it's important to have consistent tests and what that actually means. We'll talk a little bit about software correctness and criteria for correct software, some different approaches for testing your software. Then we'll talk about the anatomy of a test, the ingredients and processes in which you actually write your tests. Then we're going to take more of a deep dive into visual regression testing and kind of why I think visual regression testing is really important and super neat. Some of my favorite tools that you can use to write visual regression tests for your projects. So testing. So I joke about this a lot, but it's something that's really important. Good testing is hard, but great testing is even harder. And that's because I think that when you approach testing your software, you have to keep in mind that the time that you spend writing your tests is not the time that's actually most outwardly valuable to your end users. You aren't actually delivering new features to your users during that time that you're writing your tests. But your tests are there for a reason. I like tests because they help me sleep at night. Your goal of writing a test is to be able to pinpoint different areas of your application in which your code is breaking, or in other forms of testing, to actually write a test after you found a bug so that it doesn't happen again, or to write a correct test so that you can write code that actually satisfies it. And so you can deliver and also continue delivering a high-quality product that people enjoy using that's bug-free. So the larger that your application gets, the more features may unintentionally break as you add more code. And so one of the interesting things is that the human brain is actually really, really terrible at detecting these changes, whether they're visual or text-based. So it's much better to let a computer handle detecting changes, both visual and functional. And so on the left here, I have a screenshot, and on the right, I have another screenshot. And most of you in this room, I know it's kind of small on the screen, but even if you saw it full size, most of you would probably not be able to tell if there was any difference between these two screenshots or not. And spoiler alert, there is. So one of the huge gotchas of tests is that your tests actually only catch bugs in one of two scenarios. You actually run your tests, and two, when you've successfully written a test that properly catches your bug. So with that in mind, we know a few things. So we know that tests need to be fast so that we can run them locally, we can run them often, we can run them across different browsers and platforms, and we're not going to take the entire day for our tests to run in the background before we actually get our test results back. Our tests also need to be reliable. We really need to be able to depend on our tests. So when they're given the same input, they can produce the same output. A lot of times, this is going to be in regards to temporal bugs that are really, really hard to reproduce, whether that's from a third-party API that goes down, but you don't happen to know that it goes down because you don't write tests to test somebody else's API and you're not monitoring their API, right? Or it could be that you're running tests on a server for continuous integration and there's a maintenance outage or just a general outage and your infrastructure goes down and you don't know that your tests are breaking because of that. And you're just sitting there waiting in Slack for that little notification to come through and tell you that you can deploy. So anything like that, you want to make sure that you're tracking these changes and that you can avoid these issues as much as possible. And thirdly, you want to make sure that your tests are very modular and very direct. So one of the things that many programmers are taught as sort of a good programming paradigm and style is to make sure that your functions are small enough whatever X number of lines that you deem is that limit. Make sure that your functions are small enough so that you can test individual functionality and focus on doing one thing correctly at a time. And this is really helpful when it comes to testing, because it means if you write a test and it fails, you can actually narrow it down to the given like 10 to 20 lines in which your test is failing. Some of the things that aren't as helpful in testing is when you test too broadly. Say you're trying to test authentication, and you're trying to register a user for your app, and your test just comes back and says, user registration failed. That's it. Have fun with that. So being actually able to test individual functions and how those functions come together is really helpful, because you can start from these sort of small building blocks of testing individual functions, and then you can test how those functions are integrated together and have a much better time at actually pinpointing your errors and where they're actually coming from. So going off this, I like to borrow a lot of ideas from formal verification. I see a lot of parallels between formal verification and software testing, because the ultimate goals of both are to make sure that software is rid of errors and are fault tolerant and stable. But a pillar of formal verification is that no software is actually inherently correct. So there are two different ways that we know software is correct. And I very unabashedly pulled this example from a really excellent Medium post by a gentleman named Andrew Helber. So these are not my words, but we know that software is correct when the supreme deity of the universe descends from the heavens and decrees with the weight of objective truth that a certain piece of software is correct. Or what happens more frequently is that we have a list of things that we want our software to do and a certain amount of logic to prove that the software actually does these things. So in the first scenario, as silly as it is, what we're talking about are objective truths. We're talking about things that are not going to be debated. And also in this sort of all-knowing, all-powerful knowledge of everything that has been and everything that ever will be, everything is known by this being, right? And the thing is that that is never the reality of software testing. Functionality can be subjective. It can be ill-defined. There are going to be edge cases, always. And it can certainly be relative. So let's talk about some different approaches for testing. When you approach testing, it's common to come at it in either or both of these two ways. We can say, how do I know that this software is correct? Or, how can I break this? So the first one is saying, for example, I'm writing a function that computes the sum of two integers and returns the result. So we know inherently that we already have a set of truths and proofs that define our system of mathematics, so that we can go through and say, yes, if the input is 1 plus 1, the output is 2. If the input is 1 plus 2, the output is 3. If it's 2 plus 2, it's 4. We have this sort of rhythm and set knowledge that if we put in these two inputs, we should always get this discrete outcome. So we know that this can be applied across the board, even if we're throwing at it a positive number, a negative number, an integer, a float, whatever it is, it's already decided for us. There are no real edge cases that haven't already been defined, especially in addition. Dividing by 0, like, yeah, you should probably watch out for that one. But in a certain sense, there are no edge cases, so we can very easily set out this proof and say, okay, I can verify that this software is correct. The other more fun way, in my opinion, of approaching software is, how can I break this? So QA engineers get to be really, really great at breaking things. But the problem is that when you have these two things, you're kind of approaching the problem from two sides, and you're missing a lot of what happens in the middle. And that is where software testing fails at verifying software most often. So we can talk about what software testing looks like in theory and what software testing looks like in reality. So in theory, you're going to have 100% test coverage, and your tests are going to catch every single bug that could possibly exist in your code. But the reality is that that's not going to happen. Even if you have 100% test coverage, that doesn't mean that you're actually testing for the right things in your code. As an engineer, knowing that the number of tests that I write might help me sleep at night is great, but knowing that the less time I spend writing tests, the more time I can spend writing code and delivering features to a user is even better. So one of the ways that I've tried to optimize my approaches to testing is especially working for a company where a lot of our clients can't be convinced to have like a super full, robust test suite, is to take one of these paradigms that's very common in software engineering and focus everything around the user. So integration tests are hard. Integration tests are going to make sure that all of the different pieces of your software are working together properly and that nothing's broken. But that means that almost everything needs to have a test, which is not so easy. So I like to approach testing using something called visual regression tests. Now, the definition of regression testing is going to depend on who you ask and how they define it. A lot of times, regression testing is going to refer to when a bug is introduced into the system, you then write a test that checks for that bug, and then hopefully that exact same bug is never introduced again. But I like to think of regression testing as being a little bit more proactive. So regression tests are written to ensure that existing functionality that you have remains stable even as you're adding new features or refactoring code. So when you think about approaching your application from the end user's perspective, you can test how, say, your login page works. In this example, visually, you can see as a user, when you attempt to log in with a correct password and a properly working server and API, that you get back accurate responses from, and a working front end that you get back, that you can actually parse those responses and properly display the information. In that example, it's really, really easy to see when you look at it visually that your code is working across the board. So we know that when your username and password is correct and working properly, the user should be redirected to their home page. It's really easy to see that. If the user's email or password is incorrect, an error should occur and should be displayed. If any of the pieces are failing, you'll immediately know by looking at your visual tests. So now the biggest concern is being able to mimic and test different states of your application and your system as a whole from this single viewpoint. So let's talk about the anatomy of a test. So you have a few different ingredients to testing. So you'll have a test environment. Commonly, some of the most popular are Mocha, Jasmine, Jest, and Karma. Testing structure. You'll want to be able to kind of like define how your directory structure is going to look like and how that's all going to work. You'll need an assertions library. So Chai, Jasmine, and Jest are some of the most popular if you've seen those or used those. You can also have mocks, spies, and stubs, which we won't really get into. And then one of the most important parts for visual regression tests is that you'll need a browser or browser-like environment. And then the anatomy of a test. First, you're going to go through, you'll generate, display, and watch all of your test results, whether that's locally in your terminal or part of your CI pipeline. You'll want to compare and check your assertions that you've written in your tests, and then generate code coverage reports. And like I said, it's not important. Code coverage can be important, but making sure that you're hitting 100% code coverage does not mean that you're actually properly testing your software. So code coverage should not be a goal in your testing. Okay, so approaches for visual regression testing. Generally, visual regression tests are going to follow these same patterns. They just have a few other things sprinkled in. So they're pretty similar to snapshot testing, but instead of just taking like a tree version of your application, you're actually going to take a screenshot of it. So we'll have screenshots from the application that we're actively testing, and then we'll have something called golden images. And the golden images are going to be pulled from either mockups or a previous version of your application that was in a stable state that you want to keep it at. We'll also use an image diffing library where you can generate and compare full screenshots to make sure that if there are any changes from your previous run, that they are intended, and then you can update your golden screenshots from there. So one of the things that's made visual tests a lot easier is something called headless browsers. So visual regression tests rely on having a browser or browser-like environment. Previously, visual regression testing was tied to manipulating an actual browser and using tools like Selenium or Phantom.js. But those tools have been kind of notoriously difficult to work with, especially when trying to introspect or debug issues. So headless Chrome does make interacting with your browser a lot easier because you can control your test environments without a visual UI. If you've ever run or seen tests running on multiple different browsers that were not headless. You'll like run your tests and have like 10 different windows pop up and your computer is just like taken over by the devil. So this makes it a lot easier to work with. And visual regression testing got even easier in 2018. Puppeteer is a Google project that is a library that makes interacting with headless Chrome painless and beautiful. It is a lot easier to debug. You can actually get access into your browser environment itself and call functions. It's a lot easier to actually like click through events. It's really, really great. So let's start off with a walkthrough of an example of how you can approach visual regression testing. So for me, my tools of choice for this example, I'm going to use Puppeteer because it's really great to work with. I'm going to use a library called ResembleJS that can handle my visual image comparisons. And then I'm going to use just an enzyme because the base project that I used was a React application. So real quick, you'll have to install dependencies. This is by no means like a complete guide. I will have the source code posted so everybody can check it out. But these are kind of like our key players. So we've got Jest, Enzyme, Puppeteer, and ResembleJS. The first thing that you'll want to do is create the directories where you're going to store all of your screenshots. So you'll have your golden screenshots where you store your initial mockups or your like stable screenshots. Your test directory where you're going to store your active screenshots for what you're testing. Then I also like to store all the image diffs in case I need to go back and look at them later. So I'll also create that. So before all of your tests run, you're going to want to make sure that all these directories exist. And just a side note, I'm not an advocate for pixel-perfect mockup matching. I believe that you should let your frameworks and component libraries and CSS frameworks and whatnot, I believe that you should let them kind of do their own thing. But I think that this is a really great tool to be able to make sure that you're like getting in the ballpark for matching what your mockup should look like. I do believe in checking typography and checking alignment in your apps. So before each of your test runs, you'll want to give yourself a fresh browser and a fresh page using Puppeteer. And all you have to do that is call puppeteer.launch and then browser.newpage. So first what we'll do is we'll navigate to the route that we want to test and take a screenshot of that page. This is just a helper function that we call. This is still kind of, it's not pseudocode, but it's like kind of the pieces that come together to make all this work. So this is the helper function. It's made so that we can pass it a route so that we can easily handle testing a bunch of different pages in our application. And like I said, you can also handle clicks in different UI states using Puppeteer. And I definitely recommend, like if you're testing mobile responsiveness, make sure you're looking at what your page looks like when your nav bar is expanded, when it's closed, et cetera. So once you have that screenshot, you'll want to compare it to your golden screenshot. So what we're doing here is we are reading in our files for both our test screenshot and our golden screenshot. And then compare images is a helper function from ResembleJS that will compare those two images, and it'll spit back out different metrics on it. So it'll tell you the percent that the image is matched. It'll tell you like the color differences. They've got a bunch of different settings of how you can render this and how you can handle motion and aligning sizes and et cetera. So right after that, then I just go through and save my file, my diffed image to disk so I can look at it later. And then the only thing that I'm testing here is to make sure that the match percentage is 100%. So here's some example outcome of the test application that I have. So on the left is my golden screenshot, and on the right is my change screenshot. I think the only thing I did was like I changed the gutter on my grid and made my gutter a little bit bigger. So you can see that my screenshots actually are a little bit different sized because I made the grid bigger. And so from here, this is what we get as an output from ResembleJS. So we can actually see the parts of the image that moved, and I can go through and say, yeah, you know, we did want some extra padding on this, so this is fine. Let's make this our new golden screenshot. Or, oh man, I changed something that I didn't actually want to change. So that's one of the great things that you can do is make sure that small changes that you're making aren't impacting the rest of your app. So say, for example, if I had made the title font larger, and I changed it directly on my H3 tag. But if I changed it on my H3 tag, it's going to change it throughout the rest of my app. And maybe that wasn't my intention. Or maybe it was. But it can at least help me go back and go, oh, no, I needed to put it on my title class and not on my actual H3. So what should you expect? You knew that one was coming. If you have user stories, those are a really great place to start. If you have well-defined user stories, a list of requirements that are seen from a user's perspective that basically list out everything that your application should do, those are a great guide to start with. I think that you should start with your critical points. Figure out the parts of your application that would ruin your user experience if they didn't work. Or kind of those like really critical business logic parts that are, you know, maybe making the money for your product. Like those are going to be the things that are super important. If a user can't authenticate into your application, you're pretty screwed, right? So like start with those things. So sometimes the most complex parts of your application are actually the hardest to test, but that means they're also the most likely to break. If you don't have user stories, you can try generating a sitemap and picking out the parts that you want to start with. All right, and that is everything. This slide is actually a lie. This stuff is not hosted yet. I still need to push it up. But it will be hosted. I'll tweet about it when I get it up there. And yeah, go forth and test things.
So, testing. If you write, like tests are code.
Yeah.
So if you introduce more code, there could be more bugs. So do you have to write tests for your tests? Like how far does this go?
That's just like an infinite loop, right? Like,
yeah.
Yeah.
Yeah. Maybe we should just give up this whole web thing. Which sounds about right. But no, really, you brought up one many interesting things. The one thing that really stood out to me as someone who used to do consulting is you mentioned that like sometimes it's hard or impossible to convince clients that they need a full test suite for projects.
Yeah.
And I think that's probably one of the hardest things about testing is beyond like motivating yourself, but motivating the people that hold the cash, you know? So like, what advice would you give to somebody who wants to incorporate testing more into their workflow at work, but have to convince the people that make those decisions that it's important to do so?
Yeah, I think one of the most compelling reasons to have tests is as part of a like CI/CD pipeline, so continuous integration and continuous delivery. If you can convince the people who are in charge to allow you to have like a push-button way to deploy your software in a way that you can at least try to guarantee that your developers aren't messing it up and that you're not going to ever like push out a broken build, I think that's really important. I also think starting small, and especially with clients, being able to show them the different ways that you're testing. So like showing them screenshots of their application is going to be more motivating to them than showing them like just a bunch of tests that are passing in a terminal.
Yeah, I guess it involves a lot of like showing prior art or just being like, I'll just give you broken software if there's no tests. One of the questions from the audience comes from my buddy Harrison, DinosaurJS alum from last year. And he asked, do you have any advice on what ratio of unit to integration testing you should have?
I don't necessarily think of it as an exact ratio. Again, I think that being able to kind of leverage the ways in which you approach your testing and making sure that you're focusing on the right things is going to be so much more important than actually like having a set ratio of end-to-end versus unit tests. I think that it's best to figure out like the parts of your application that are the most important and test those thoroughly first. And if that's just an integration test to make sure that your API call is working or that different parts of your software are working together, that's great. But again, like being able to pinpoint the areas that your code is breaking is going to be the most important. So I kind of lean towards unit testing. So I don't know.
It's a case-by-case basis, right? Whatever you want to do, Harrison, you do you. These testing suite stacks all sound like Starbucks drinks.
Yeah.
So what is your favorite testing suite stack, if it's not the one that you'd shown up before? And what's your favorite Starbucks drink? Mine's mocha chai jest. Grande.
So if it's a React application, I do kind of lean towards stress and enzyme. But otherwise, I really like mocha and chai. All jokes aside.
There are no jokes up here. This is all serious.
Very serious.
I have a reputation to uphold.
Oh, God. I used to be a really terrible Starbucks drink orderer. I used to get like an iced grande, triple upside down, extra caramel macchiato.
Triple upside down. What the hell does that mean? It sounds like my tests.
Sounds like my software. Yeah, and then I got a job at Starbucks, and I was like, wow, I'm an awful person. I'm never ordering that again.
It's kind of like jumping into someone else's code base with the Bananas testing suite setup. See, there are parallels there. People try out working in the restaurant service for a while, and you'll have a better idea on how to navigate code. Well, thank you so much. That was excellent. Way to kick off the event. Thank you very much. Round of applause for Emily.